I've created a parabola in GeoGebra. This is the green parabola. The formula for it is ax squared plus bx plus c equals 0. That's our functional value over here. And we have sliders for the values of a, b, and c. We're going to change these sliders and see what effect it has on our parabola. I've also created a formula over here, b squared minus 4ac, which is our determinant or discriminant. It's being indicated by the red line here. And different things happen with our parabola, and we'll see what happens when our discriminant is positive and when our discriminant is negative and when our discriminant equals 0. If we change our a value of our formula, you'll see that since a is multiplied by x squared, if you increase the value of a or decrease it below 0 more, it makes the values of the function increase or decrease much more, so it becomes much skinny looking. Incidentally, when a equals 0, as it will there, when a equals 0, you have no x squared term, therefore you actually have a line. Our b term, let me make that more of a parabola again. Our b term changes where the vertex of our parabola is. It kind of moves in a parabola itself. And you can see that changes the roots of our parabola. You can see our discriminant line moving as we change our parabola, our b. Now if we made a bigger, now we'll make it smaller, make it a wider parabola, and we make our b lower or higher, we get it above that line. We might have to change it a little more. Actually, let me raise our c because it changes it vertically. Now I have a parabola with the vertex that is above 0, and it extends up in the upper to the positive, so it doesn't cross the x-axis. There are no roots. Therefore, our discriminant is now below the x-axis. It is negative. And when you have a negative discriminant, you have no real solutions for your parabola. Our c value changes up and down, or vertically, where our parabola's vertex is, which makes sense because you're not multiplying it by the x. The b value changes where the vertex is located. It goes up and down as we cross. Now here we crossed the x-axis. Now we can visually see that we're going to have two real solutions. Our discriminant also is positive, which also tells you you're going to have two real solutions. If that discriminant happens to be a perfect square, then you'll have two real rational solutions. Otherwise, you have two real irrational solutions. And when our discriminant equals 0, if we move our b so that the vertex is right on the axis, I think that's as close as I can get it, just about. So that our b squared minus 4ac is 0. That's pretty close. B squared minus 4ac is going to be very close to 0. Our discriminant is 0. We're going to have the one root. If I could manipulate this so that the red line was right on the axis, we'd have one real solution right there where it touched. And that's when your determinant, your discriminant, equals 0. Your parabola will come down and touch the x-axis, or come up and touch the x-axis as it goes down, since it faces down, and therefore you'll still have the one solution. So we have four real cases. Either our discriminant is positive and a perfect square, which gives you two real rational solutions. Our determinant can be positive and not a perfect square, which gives you two real irrational solutions. Your determinant, the red line, could be on the 0, on the x-axis, in which case you would have one solution where the vertex of the parabola is either positive or negative. Or if the determinant line falls below the x-axis and is negative, then you will have no real solutions. In that case, you'd have a parabola where the vertex is positive, opening to the positive direction, or you have a vertex that is negative, opening to the negative direction. Either way, it will not cross the x-axis and give you any real roots. Thank you.